Hey everyone, welcome. So today we're going to talk about a mind-blowing new AI that can literally predict diseases from a single night of your sleep. But what's really fascinating, and kind of the whole point of this, is what this incredible leap forward actually tells us about a huge hidden flaw in how we think about health and medicine. So let's start with this number, 130 plus. Just look at that for a second. What on earth could that possibly mean when we're talking about your health? Well, that's the number of different medical conditions that a new Stanford AI called Sleep FM can predict just by looking at one night of your sleep data. It's absolutely wild. It does this by chewing through more than 500,000 hours of sleep recordings, finding these tiny patterns that are completely invisible to any human doctor. And that brings us to our first idea here. You really have to think of Sleep FM as a kind of technological marvel, like a superhuman sleep doctor. We're talking about predicting really serious stuff, Parkinson's, diabetes, heart disease, sometimes years, and I mean years, before a person ever shows a single symptom. All from your sleep. I mean, the scale here is just staggering. It was trained on this immense data set, and it achieves a score called a concordance index of over 0.75. So what does that actually mean? It means if you take two random people, one who's going to develop a condition and one who won't, the AI can correctly pick out the higher risk person more than 75% of the time. Doing that across more than 130 conditions, that's a whole new gold standard. Okay, but here's where the story takes a turn. What if this incredible power, this almost magical ability, is actually built on a really shaky foundation? Let's get into it, because the problem isn't the AI itself. It's the box we're forcing it to think inside of. And that right there is the heart of what we're talking about today, the binary trap. You see, the issue isn't a bug in the code. It's way more fundamental. It's about how our computers are built from the ground up to see the world, in ones and zeros, black and white. This slide just lays it out perfectly. On one side, you have biological reality. Our reality. It's a world of smooth spectrums, gradual changes, endless shades of gray. But on the other side, you have binary AI. It only gets discrete boxes to put things in. Yes or no, sick or healthy. It's literally like taking a beautiful, rich, colorful photograph of your health and saving it as a pure black and white image. You lose all the important details in between. Right, think about something like high blood pressure. In the real world, it's not like a light switch that just flips on one day. No way. It exists on a smooth, continuous spectrum, just like this gradient you see here. Your blood pressure creeps up or down over time. There's no single magic line where you suddenly cross over from healthy to diseased. But here's what the AI has to do. It takes that smooth, real-world spectrum, it forces it through its binary filter, and bam, it collapses it into one of two buckets. It just crushes that beautiful, nuanced gradient into two simple blocks, diseased or healthy. And in that process, all that incredibly valuable information about where you are on that spectrum just gets thrown away. And this is the key takeaway, and the researchers put it so well. The labels our AIs learn, like hypertension, aren't some fundamental truth of biology. They're just convenient lines in the sand that we humans drew to make decisions easier. They're practical, for sure, but they're not real in a biological sense. So, if the problem is this black and white thinking, what's the solution? Well, the answer might be to build computers that can actually think more like our bodies work, in all those shades of gray. And here are a couple of really cool ideas for how to do that. First, you've got something called fuzzy logic, which is all about embracing those in-between states. The best analogy is a dimmer switch. It's not just on or off, it can be 20% on or 70% on. Then there's neuromorphic computing, which tries to actually copy the wiring of the human brain. Think less like a single straight highway and more like a massive city grid with countless little pathways all interconnected. Now, with these new ways of computing, we could unlock a way richer and more powerful way of seeing our own health. It's really about shifting from these simple labels to creating detailed, personalized maps. So, this is the old way of doing things. You get a disease label, a single static tag. Boom, you have hypertension. It's simple, sure, but it's also a huge oversimplification of what's actually going on inside your body. But this is the future. Instead of a single label, picture a state manifold, a dynamic, multi-dimensional map of your body's unique state. It's like having a detailed topographic map of your personal health, showing you exactly where the gentle slopes, the steep valleys, and the dangerous cliffs are. It's a whole landscape, not just a dot on a map. The researchers behind this put it just like this. They're proposing we see our health as a specific coordinate on this incredibly complex, continuous map. It's a huge shift, right? From just getting a simple label to finding your precise location. So how do we predict the future with a map like this? Not with a single simplistic risk score. No, we use something called trajectory bundles. This is a much more honest and realistic way to look ahead. You know how a modern hurricane forecast doesn't show one single line, but that whole cone of uncertainty with lots of possible paths? It's exactly like that. It shows us a whole collection of possible futures. So, what does all this add up to for the future of diagnosis? Well, it means we're right on the edge of a massive change in how we think. We're moving beyond just getting better answers to our old questions, and we're finally starting to ask completely new ones. Because at the end of the day, the real goal is to evolve. We need to get away from AI that just slaps a binary label on you and move toward an AI that helps us see our health for what it really is, a dynamic, continuous story that's always, always changing. And that really leaves us with this final big question to chew on. Is the real promise of AI in medicine just about getting more and more accurate answers to the questions we're already asking? Or is its true power in helping us see our own bodies in a totally new light and to start asking questions we never even knew existed?